In this lesson, we will review an example single-line diagram for the in-phase IQ8 commercial system. After this training, you should be able to understand a typical IQ8P-3P single-line diagram and identify what in-phase components are required. Let's review an example single-line diagram for a 100 kilowatt system using the IQ8P-3P microinverter. This example is using 180 IQ8P-3P microinverters and is connected by a backfed breaker. We will start by taking a closer look at the branch circuits on the left side of the diagram. To identify how many circuits we need, just take the total number of modules or microinverters on the project and divide by 12, since 12 is the maximum number of micros each circuit can have. In this example, we have 180 modules, which leaves us with 15 branch circuits, 12 microinverters in each. If your circuits do not work out this evenly, try to do as many as you can with 12 microinverters in each circuit. Then have the remaining circuits split into multiples of 3. This helps keep phases balanced. Next, you can see that each circuit calls out for center feeding. Center feeding is simply where we will connect our home runs to pull power from each circuit. Center feeding is required on every circuit that has more than 6 microinverters. Now let's look at what in-phase components we will need in each circuit. First, we have the IQ8P-3P 208-volt microinverter with EN4 to MC4 adapters that each module will plug into. Next is the QD cable, which comes in 3 different lengths, has connectors pre-installed that easily plug into each microinverter, and has center feeding connectors pre-installed after every 6th micro connector. The center tap adapter is needed to plug into the center feeding connectors on the QD cable, and 1 per circuit is required. Now we have our QD terminators that get installed on each end of the QD cable for each circuit. 2 per circuit is required. Next is a male field wireable connector that will get plugged into the center tap adapter on each circuit. 1 per circuit or center tap adapter is required. Lastly, we have the raw QD cable. The raw QD cable is a 4-wire 12 AWG cable that gets connected to the male field wireable connector to create our home runs and take the power from each circuit back to an AC PV sub-panel board or combiner panel. Next on the single line diagram are the circuit home runs and the AC PV sub-panel board or combiner panel. Up first are the home runs from each circuit. In-phase raw QD cable can be used as home runs to take the power from each branch circuit back to the AC PV sub-panel board, or you can transition from the raw QD cable to whatever conduit and wire you require. Next is the AC PV sub-panel board or combiner panel. This is a non-in-phase product and should be sized for the specific project. Each circuit will get connected to a 20 amp 3-pole breaker. The main breaker should be sized accordingly. The IQ Gateway Commercial 2 does not have to be installed in the AC PV sub-panel board. It does need to be installed close to the microinverters, and it must be powered by a 3-pole breaker up to 20 amps. Wi-Fi and Ethernet is included, and the gateway comes with 3 revenue-grade production CTs. Lastly, on our single line diagram journey, we will review from the AC PV sub-panel board to the point of interconnection. Line filters are only needed if the site has multiple gateways or there is line noise from machines or other devices. Conductor and conduit type and size shall be determined by the designer. Size, number, type, and location of disconnects shall be determined by designer. Interconnection method is dependent on site conditions and size of existing panel board. Consumption CTs are optional and need to be wired to the gateway. If you are not sure that your design is correct, Let us review it for free to make sure it is correct and it is ready for permitting. All you need is an Enlighten account, then navigate to Design Services under the Services dropdown. Fill out the required information and upload a minimum of your single line and site plan. Once your design is complete, you can use our System Builder tool on the Enphase website to create a custom bill of materials for your project. This will give you all the required Enphase products as well as third-party products that you will need to complete your system.